Colby, 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 math.com.
We're practicing the exponent laws that we learned today in class. I'm going to do problem number 24 with you. 24 is a great problem because it combines every one of the exponent laws that we learned and also gives us a chance to practice solving an algebraic equation, which is the way we began this unit on algebraic reasoning. So let's start by finding this product, 8 to the second multiplied by 8 to the 10th. And just remind ourselves of the law we learned when the bases are the same. So for example, if we had 5 squared multiplied by 5 cubed, we would have 5 times 5 multiplied by 5 times 5 times 5. So that's obviously the same as 5 to the 5th power. So when you have the same base number, you simply add the exponents for that reason. And so 8 squared multiplied by 8 to the 10th would be 8 to the 2 plus 10, or 8 to the 12th. I'm going to rewrite the rest of this equation. 8 to the 12th to the w divided by 8 to the 3rd is equal to 8 to the 33rd. If we had, for example, 5 cubed squared, that would be, our base now is 5 cubed. So 5 cubed multiplied by 5 cubed. And we just said if we have the same base number, we can add the exponent. So this would be 5 to the 6th. But we see we can also get that by multiplying the exponents. So when you have a power of a power, you multiply the exponents. So applying that exponent law to our numerator, our expression on our numerator, 8 to the 12th to the w is the same as 8 to the 12w. Writing the rest of the equation, divided by 8 to the 3rd power is equal to 8 to the 33rd. Now if we have 5 cubed divided by 5 squared, if we expand the numerator and the denominator, we have 5 times 5 times 5 over 5 times 5. And these 5/5 cancel, these 5/5 cancel, and we're just left with 5, which is 5 to the 1st power. But we see we can also get that by subtracting. So 3 minus 2 is 1. So 8 to the 12w divided by 8 to the 3rd power is 8 to the 12w minus 3. And that's equal to 8 to the 33rd power. Since we have the same base here, this expression must equal 33. So we have 12w minus 3 is equal to 33. And this is a two-step algebraic equation similar to some of the problems we solved on the first days of this unit. So I'm going to ask you to pause and use inverse operations and isolate this variable to identify the variable value, and then substitute to verify your value to make sure it's correct during the pause, and then come back and see how you did.
Paused.
And when I go through this solution, I'm going to do a lot of extra steps and talk about, because I want to take the advantage of the opportunity to talk about all the properties. You're not required to write the whole proof like we did on the first day of this unit, but I just want to remind you of some of the reasons why we solve these algebraic equations the way we do. The first thing is I want to isolate the variable. So before I can do that, I need to isolate the variable term. So I need to get rid of this constant term of negative 3. Remember, subtracting is the same as adding the opposite, so minus 3 is the same as adding negative 3. If I combine negative 3 with positive 3, then I'll get a constant term of 0, which is what I want. I want to undo this subtracting 3 with adding 3, but I have to do it on both sides. That's property of equality. 33 plus 3 is 36. So now we have 12w plus 0 equals 36. We added opposites and got a sum of 0. That's the additive inverse. And we did that to identify 12w because 12w plus 0 is 12w. That's the additive identity. So now we have 12w equals 36. But I'm not trying to find what 12w is. I'm trying to find what w is. W is 1w. And you can undo multiplying by 12 with the inverse operation, which is dividing by 12. But I have to do it on both sides because of property of equality. 36 divided by 12 is a quotient of 3. and 12 divided by 12 is 1. So 12w divided by 12 is 1w. You can also think of this as, we know dividing is the same as multiplying by the reciprocal. So dividing by 12 is the same as multiplying by a 12th. And when we multiply reciprocals, we get a product of 1. That's the multiplicative inverse. And 1w is w. That's the multiplicative identity. We've identified w as 3. But to make sure we did it right, we should substitute w's value back into the original equation. Well, this was the original equation. So if I substitute 3 here, 8 to the 12th to the 3rd is 8 to the 36th. And when I subtract the 3 in the denominator from 36, I do in fact get 33. And so that verifies the value of w. If we did it using substitution in this equation, it would be 12 multiplied by 3, substitution. 36 minus 3, 36 minus 3 is 33. So that shows you the reflexive property, which verifies the variable value, so w equals 3. I hope that helped with the assignment. I'll see you tomorrow.